In this final example, we're being asked to use conservation of energy to analyze some rolling objects down an inclined plane. So, as we're being shown here, rolling motion has the property that the velocity is equal to the radius times the angular velocity, which we're going to use in the solution. In this particular situation, I'm going to try to draw it out. It's basically an inclined plane, and objects are being raced on it, different objects. So the main objects that we're being asked to see which is like the fastest one that reaches the bottom of the ramp is a hollow cylinder and a solid cylinder. So we have these two cylinders here, and one of them is hollow and the other one is completely solid. So right here we have the x-axis, and then this portion is the height. So we need to get straight a few values before we start tackling this problem. The kinetic energy is equal to 0 in this case. The initial kinetic energy, at least. And we also know that the final velocity, when they reach the bottom of the inclined plane, is also 0. And then we know that the overall displacement would be 2 pi times the radius. And this is also equal to the change in theta times the radius. And then the change in theta would be 2 pi once we work both of these out and kind of isolate the displacement of theta. And then when we're trying to find the final kinetic energy, it would be half of the mass times the velocity squared plus half of the inertia times the angular velocity squared. And then the angular velocity in general would be the velocity over the radius. And these are the main equations that we're going to be using to compare these two objects and see which one is faster. When we're talking about the hollow cylinder, we're going to try to find its velocity. The inertia of the hollow cylinder is going to be equal to the mass times the radius squared. And then the inertia, we know it's going to be 0 plus the mass times gravity times the height, because this is the force acting on the cylinder as it's going down the plane. And this is going to be equal to half of the mass times the velocity squared, as we mentioned before, plus half of the mass times the radius squared times the velocity over the radius squared as well. And then here we can start canceling out a bunch of values. We can cancel out the mass. We can also cancel out the radius and squared. And after we solve all of this and kind of isolate the velocity, which is what we ultimately want, we would get the square root of gravity times height. So that's the velocity for our hollow cylinder. And now moving on to the solid cylinder, we would follow the same process. So for the solid cylinder, we would get the inertia is equal to half of the mass times the radius squared. And then again, we'll do the same thing. 0 plus mgh is equal to the mass times the velocity squared plus half times half of the mass times the radius squared times the velocity over the radius, and then we square that whole equation. And again, we can cancel out the masses, we can cancel out the radius, and our final calculation when we isolate the velocity is going to be the square root of 4/3 times g and h, the gravity and the height. So now that we have both of these values, we know that the hollow cylinder is we know that the hollow cylinder, the value was the square root of gravity times height. And then for the solid cylinder, we know that the value was the square root of 4/3 times gravity and the height. And then in this case, the solid cylinder is faster